So, now let us see the pressure inside a bubble. So, again we will use the same three method. First method. So, let us see the first method, that is excess pressure formula. We will be using it. So, now a liquid bubble is something in which we have air inside and outside air and inside air, and we have a thin, this is thin skin of a liquid. So, we will magnify this portion so that you can see here, this is thin film. Actually, this thickness T is very small. So, we have some points. Suppose I say this is 1, this is 2 and this is 3. I have 3 points, 1, 2 and 3. Suppose this surface has a radius R1 and this surface has a radius R2, such that if I say this is R, then I will say that R1 is equal to R2 is equal to R. So, this thickness T is very small. So, now applying, so now we have the excess pressure formula 2S by R for spherical surface. So, now applying the excess pressure formula, so applying excess pressure formula about the inner surface. Suppose I say this is S in and S out. So, inner surface. So, inside the pressure of 1 is greater than 2 by 2S by R1. Now, applying excess pressure formula about the outer surface. So, we have P2 is concave side, which is greater than P3 by 2S by R2. So, now let us add up 1 and 2. So, we have adding 1 and 2, we get P2 cancel, P1 minus P3 is 2S by 1 by R1 plus 1 by R2. Now, P1 is pressure inside, P3 is outside pressure, 2S by 2I by R because they are same. So, that is equal to 4S by R. Thus, inside pressure is greater than outside pressure by 4S by R. So, now let us come to the second method, that is equilibrium of forces. So, second method, so equilibrium of forces we will use, that is the force method. So, what we do now, this time we will consider the equilibrium of semi bubble. So, you see it is a semi bubble. So, here we have an outer one and here we have also the inner one, so that the thickness is very small. So, we have the force from outer one and the force from inner one also. Inside pressure is suppose P into pi r square is the internal force in this. Remember, we have to take cross section, and external force will be also equal to P into pi r square. This is P naught external. Now, you see the external force is acting in all directions. So, the resultant of which is given as a downward P naught into pi r square, because this component and this component cancel, simply all the vertical components is going to be added. So, only projection area should be taken. And what is the surface force? So, for outer one 2 pi r into S, and from inner one 2 pi r into s. These are the surface tension force. So, consider the equilibrium of the semi bubble. So, other part of the semi bubble is applying this force. So, total downward force we see P I r square plus 2 pi r into s plus 2 pi r into s is equal to P pi r square. Implies we have P is equal to P naught plus 4 pi r s by pi r square. Pi cancel, 1 r cancel. So, we have P is equal to P naught plus 4 s by r, which is the same result which we got by excess pressure formula. Now, let us see, again we will derive this result with the help of virtual energy method. Now, third method is the virtual energy method. Virtual energy method. So, now let us consider a bubble. This is the bubble. So, I have to show you a finite. So, you see this is the skin of the liquid. So, the liquid is there and we have air inside it and outside it. So, this is the air inside and it has a radius r, and you see its radius increases fictitiously. So, consider a bubble of radius r with a thin skin, that is its surface is very thin. Let due to imbalance due to imbalance in excess pressure its radius increases by dr. So, we have area as 4 pi r square outside and 4 pi r square inside, that is 8 pi r square. So, the change in area becomes 16 pi r dr. This is the change in area. Now, the volume enclosed it. Now, volume enclosed is 1 by 4 by 3 pi r cube, and so change in volume will be, this 3 will come here. So, 4 pi r square dr, this will be the change in volume. Now, the work done by the excess pressure force per unit area, i.e., which is basically the free energy of the surface, is equal to, that is the work done by excess per unit area is equal to the surface tension, that is dW by dA is equal to S, implies dW is equal to SdA. So, now dW is excess pressure P into dV, the change in volume, that is 4 pi r square dr. S into change in area is 16 pi r dr. So, dr pi 1 r. So, excess pressure becomes this 4 times 4. So, this becomes 4s by r. So, internal pressure inside is P outside plus 4s by r. So, thus for a bubble the excess pressure is 4s by r. For a liquid drop it is only 2s by r. Now, let us see what is the pressure inside a bubble formed inside water. So, we have a surface of water and we have a bubble here. Everywhere we have water, and you see inside it is air. So, bubble means this is a cavity with air inside it. So, take 1.1, another 0.2. So, applying excess pressure formula. So, applying excess pressure formula only. So, you see P1 minus P2 is equal to 2S by small r. So, P1 will be P2 plus 2S by r. There is only one surface, and you see if it is at a height and here it is P naught as atmospheric, P2 is P naught plus the hydrostatic pressure H rho g plus 2S by r. This is the pressure inside this liquid. As it goes on above, you see H decreases and you see the pressure also decreases.